Hello, glad to be back here with you. And we have, as usual, a math puzzle to start the lesson. And today is a yummy one. It's one of my favorite topics. It's about pizza. How many whole pizzas can you see in the picture? And look at the picture. Don't count this one on the hand of this little boy. Just the ones that are here on the big picture. Okay. Try to figure it out. Maybe you can use fractions. Maybe you can rearrange and find out how many whole pizzas can you see in this picture. Okay, this is just a warm-up, and the lesson today is about graphs and functions, chapter 3, and we will work on section 3.4, the slope of a line. Objective is going to be find the slope of a line given 2 points on the line. And let's start with a definition. The slope m of the line containing the points x1 and y1 and the points x2 and y2 is given by show here the formula that we're going to use, m, and m is the slope. The slope is always rise over run, but we can calculate by the change in y over the change in x. The change in y is going to be y2 minus y1, and the change in x is x2 minus x1. This is the formula that we will use to find the slope of a line given 2 points of this line. Remember that x2 different from x1. We need to have different axes, different positions on the x-axis. And we will apply now in an example. Find the slope of the line through the points x equals 0, y equals 3, and x equals 2, y equals 5. Graph the line. We will use the formula m equals y2 minus y1 over x2 minus x1. We can say this is 1, this is point 1, and this is point 2. And we will be able to calculate y2. y2 is here, 5, minus y1. y1 is 3 over x2 is 2 minus x1, 0. 5 minus 3, 2. 2 minus 0, 2. The slope is equals to 2 over 2, 1. 1 is the slope we are looking for. If you look at the graph, we have the points already here. We can draw the line, and since the slope is a positive number, we will notice that this line is going upwards. We always move on the graph, on the rectangular coordinate system, from the left to the right. So I will make a little drawing here, just to, if we are moving here, this guy is walking, he needs to walk from the left to the right, and then the graph is going upwards. If the slope is positive, the graph goes upwards. And let's work on another example. And now we have m. We're going to apply the same formula, right? It's going to be the same formula for m equals y2 minus y1 over x2 minus x1. This is the formula of the slope if you have 2 points of the line. and we can say this is point 1, this here is going to be point 2, and m equals y2, 2 minus y1, negative 3, over x2, 2, minus x1, 4, minus 4. 2 minus negative 3, negative is negative positive, 5, and 2 minus 4, negative 2. Therefore, m equals negative 5 over 2. This is the slope we are looking for. Remember, slope is rise over run. If we are going to represent the line, and the points are already here, the line is going to look like this. And notice that if we think about the guy walking from the left to the right, let's try to draw the guy here. He's walking from left to right, and now he's going on this line here. He's moving downwards. Okay. If you have the slope as a negative number, the slope is a negative number, the line goes downwards like this. Helpful hints. When finding the slope, it makes no difference which point is identified as point 1 and which point is identified as point 2. See here, we assume this is as point 1, this is as point 2. We can switch, we can use either one. Doesn't matter. At the end, the result or the answer is going to be the same. Just remember that whatever y value is first in the numerator, its corresponding x value is first in the denominator. You just have to be coherent. You just have to adopt one as the point number 1 and the other one as the point number 2, and keep using the same all over your question, your solution. Okay, next objective, number 2, finding the slope given an equation. When a linear equation in two variables is written in the slope-intercept form, and this is the slope-intercept form, m is the slope, and x equals 0, y equals b is the y-intercept of the line, right? Let's try an example. Let's say we have y equals 3x minus 4. Therefore, m equals 3, right? M, the slope equals 3, and y-intercept x equals 0, y equals negative 4. Okay, clear? Easy? If you have the equation on the slope-intercept form, it's very easy to identify slope and y-intercept. Let's work on this example. Find the slope of the line. Negative 3x plus 2y equals 11. The first step, let me write again the equation here. Negative 3x plus 2y equals 11. To find the slope is we need to rewrite this equation using the slope-intercept form. Remember, the slope-intercept form is this, as we have seen, y equals mx plus b, right? So we will move everything to the right-hand side of the equation, and we'll keep only y on the left-hand side, okay? To do this, we will apply addition property of equality and multiplication property of equality when necessary. The first thing we can do, we can add 3x on both sides, and as a result this is going to be simplified, and we have 2y equals 3x plus 11. The next step, let's multiply both sides of this equation here, applying multiplication property of equality by 1 over 2. Right? So the result is going to be y equals 3 over 2, 3 over 2x plus 11 over 2. The question here is, this is the slope-intercept form, find the slope of the line, and we can answer the slope m equals 3 over 2. That's it. Another example to work on, we have this question here, find the slope of the line negative y equals 6x minus 7. So let me rewrite here, negative y equals 6x minus 7. Again, remember the slope-intercept form is y equals mx plus b. What's different here is just one little thing. It's the sign, right? We have negative x. And we will apply multiplication property of equality. We will multiply both sides of this equation here by, and let me squeeze here, negative 1. Let's multiply both sides by negative 1. We have as a result y equals negative 6x plus 7. And m is this, the coefficient of x, negative 6. This is going to be the answer. Okay, done with the example. Let's move to objective 3, interpreting slope-intercept form. And going straight to an example. The adult one-day pass price y for Disney World is given by, and we have an equation, y equals 3.53x plus 67.39, where x is the number of years since 2006. And as we can imagine, looking at it, the price is increasing over the years, right? According to this equation. Use the equation to predict the ticket prices for 2026. Well, if x is the number of years since 2006, 2006 is the year number 0, is the starting point of counting the years, right? So we can calculate x, the number of years since 2006, by subtracting 2026 minus 2006. And then we will find the number of years is going to be 20 years. Use the equation. Now bring here the equation, y equals 3.53, and to find out the answer, we need to plug in the number of years here, right? Times 20 plus 67.39. Well, you can get your calculator, type these numbers, type this math here, these operations here, and you will find as a result that y equals 137.99. This is the answer to the question on how to predict the price in 2026 by using a slope-intercept form equation. Next, we have here objective number 4, finding slopes of horizontal and vertical lines. Those are special cases, and we will see each one. At the end, you will, every time you see a horizontal line and a vertical line, you're gonna answer real quick, real easily, what is the slope of each one. Find the slope of the line x equals -2. Well, think about it. We can use, just as an exercise, we can use the formula of the slope, m equals y2 minus y1 over x2 minus x1, okay? Just as an exercise. If we have the x equals -2, that means, let's say if y equals, let's say 0, x equals -2, always. If y equals 1, x equals -2. No matter the value of y, x is going to be always equals to -2, right? So keep this in mind. We will assume this point here as point 1, and that other one as point number 2. So let's say this is point number 1, this is point number 2, and you're going to plug in the values, the numbers, into the formula. Again, just an exercise to understand. And y2 is going to be 1, y1 is 0, over x2, -2, minus x1, -2 as well. Look what happens when you try to calculate this, when you try to find out this slope here. You will have m equals 1 over -2 minus -2, 0. And this is undefined. Undefined. Okay? That means you don't need to calculate every time you see the question asking about the slope of x equals a number, or that means a vertical line. You will say that the slope is undefined. All vertical lines are going to have undefined slope. Look the explanation here. For any 2 points, the x values will be equal to the same real number. The denominator in the slope formula is equals to 0, but the numerator is going to be different from 0. So the slope is undefined for any vertical line. Now we have another situation, another example. And the question here is, find the slope of the line y equals 3. Let's do the same thing, the same exercise. If x equals 0, y is equals to 3. Doesn't matter. If x equals 1, y equals 3. If x equals any number at all, 1, 2, 3, 4, 5, y equals 3, right? This is a line where no matter the value of x, y is always going to be equals to 3. Just as an exercise, let's try to apply this into the formula. y2 minus y1 over x2 minus x1. And check what happens. And we will have here on the denominator x, let's say this is point 1 and this is point 2. Okay, let's say we have here point 2 is this, and point 1 is this. x2 is going to be 1, x1 is 0, and y2 is 3, y1 is 3. look how interesting. M equals 3 minus 3, 0, and over anything, 0 over anything different from 0 is just 0, right? The slope is going to be 0. That means if we have an equation like this, y equals a number, the slope always is going to be equals to 0. For any 2 points, the y value will be equal to the same real number. The numerator in this loop formula is equals to 0, but the denominator is going to be different from 0. And then the conclusion is, for any horizontal line, the slope is always equals to 0. Another interesting thing we can say about slopes, we have seen a little bit it before. If you have the positive slope, the line goes up, goes upwards when you move to the right. And if you have negative slope, the line goes downwards when you move to the right. Okay, now objective number 5, compare the slope of parallel and perpendicular lines. Two lines that never intersect are called parallel lines. They have the same slope and different y-intercepts, unless they are vertical lines which have no slope at all, has undefined slope. And two lines that intersect at a right angle, they are called perpendicular lines. Two non-vertical perpendicular lines have slopes that are negative reciprocal of each other. And look here at the picture. If one has slope equals A, the other one that's perpendicular is going to have slope equals -1 over A. To find out if they are perpendicular, the best way is to multiply the slopes. If you find the result of the multiplication to be equal to 1, then the lines are perpendicular. You can say that the lines are perpendicular. Let's try here one example. Determine whether the line 6x plus 2y equals 9 if it is parallel to the line -3x minus y equals 3. And the first thing, you have to find the slope of each line. Okay, so that's what we're going to work on. The first line, let's split the screen here. On the side, let's calculate the slope of 6x plus 2y equals 9. Okay, and on the other line, on the other side, we're going to calculate the slope of -3x minus y equals 3. Change the equation, each equation of the line into the slope-intercept form. So move everything to the right hand side and keep only y on the left hand side. To move the 6x, we will subtract, apply addition property, and we'll add -6 from each side of the equation, right? So 2y equals -6 plus 9. Now we can apply a multiplication property of equality and multiply both sides by 1 over 2. Let me move this line a little bit further. Multiply both sides by 1 over 2. Oops. And then we can simplify, we have y equals -6 divided by 2, -3x, and 9 divided by 2, we can just write 9 over 2. This is one of the slope-intersect forms. Now let's find the other one. And we want to move everything to the other side and keep only y on the left hand side. So apply addition property, add 3x on both sides. Then we have negative y equals 3x plus 3. Then we can multiply both sides by negative 1. Okay, multiply both sides, and then you will have y equals negative 3x minus 3. Compare the slope of each equation, and we have one of the slope sources is here, m equals negative 3, and the other slope is right here, m equals negative 3. They have the same slope, they have different y-intercepts. That means, yes, the lines are parallel. Right? The lines are parallel. Determine whether the line x plus 3y equals negative 15 is perpendicular to negative 3x plus y equals negative 1. Again, let's find the slope of each line. And I will write down on this side x plus 3y equals negative 15. On the other side, negative 3x plus y equals negative 1. Now we find the slope for each equation, transforming the form into the slope-intercept form. On the left-hand side, add negative x on both sides, and then you will have 3y equals negative x minus 15. Then you can now apply multiplication property of equality and multiply both sides by 1 over 3. Both sides we can multiply by 1 over 3, right? And simplify here, y equals negative 1 over 3 x minus 15 divided by 3, 5. Okay? This is the slope-intercept form of one of the equations. Now let's find the slope-intercept form of this and the other one. Add 3x on both sides. So now you will have y equals y equals 3x minus 1. And that's it. It's already done. It's already in slope-intercept form. We can compare. We can compare now. And the slopes, you can see they are different. So they are definitely not parallel because the slopes are not the same. Let's check if the slopes are, if the lines are perpendicular. And then you get this slope here. Let's say m1 equals negative 1 over 3. And this slope here, let's say m2 equals 3. Multiply m1 times m2 equals negative 1 over 3 times 3, and this is equals negative 1. When you multiply the slopes and find negative 1 as a result, as an answer, you can say yes, it is perpendicular. Yes. the lines are perpendicular because we multiplied and found the result as -1. And check this now. First, let's calculate the slope for this equation. Let's say number 1, -5x plus y equals -6. Remember that we will apply addition properties of equality to move everything from the left hand side to the right hand side and keep only y. So we can add 5x on both sides. Simplify y equals 5x minus 6, right? The slope here, m equals 5. Now let's work the next one, the equation number 2. And we have some space here. Equation number 2 is x plus 5y equals what? Equals 5. Same thing, apply addition property and add -x on both sides, so you can get rid of x from the left hand side. We will have 5y equals -x plus 5. Now we can apply multiplication property of equality and multiply both sides of this equation by 1/5. Right? That means simplify 5 divided by 5, 1, y equals -1/5 x plus 5 divided by 5, 1. This is number 2, equation number 2. M here is equals to -1/5. If you compare to m, the previous one, they are different, right? M equals 5, m equals -1/5, but you can multiply 5 times, and this one is -1/5. What's the result? What is the result, the number that you will find of this multiplication? 5 times -1/5 is -1, right? That means if you found to be -1, they are perpendicular. Yes. That's it. This is the last example, the last work on section 3.4. And now let's go back to our pizza, to our the puzzle, the math puzzle of today. What do you think is going to be the right answer? And let me tell you something here. You can use fractions. If you're good at fractions, you can say this kind of pizza here is a 6 slices over 8 slices. The total is 8 slices for each pizza, and you're gonna have 4 like that, right? Plus, and this one is gonna be 4 slices for 8 slice pizzas. You also have 4 like that. This is one way. You can calculate like this, or, and maybe it's easier, you can just combine. Let's say we combine the slices and make whole pizzas. 1, 2, and we can combine these 3, 4 pizzas, and these 2 halves makes a total of 5 pizzas. So the answer of this math puzzle is 5. We have 5 pizzas. All right. Thank you for watching the video, and once again, I hope to meet you again on the next section.